Good morning once again, grade 11. As I have mentioned to you last time, we'll be discussing about the anatomy of disasters. So what should be expected from these lessons? Of course, at the end of the lessons, you are expected to understand how the plates move, identify various earthquake hazards, and of course, recognize the natural signs of an impending tsunami. So as we have discussed last time, I have already mentioned the concept of the tectonic plates, given the idea of Alfred Wegener and also Harry Hess about continental drift theory and the seafloor spreading. Along with their idea, it has been revealed also that there are organisms or remnants of organisms that can prove the existence or that can prove the idea that the continents that were separated in the modern time were once united and is known as Pangaea. And these water bodies which was divided in between the continents is known as Laurasia before, or Pantalasa rather. Okay, so let me talk about active faults now. So it pertains to or it is being studied by geologists. So these are the scientists that specifically studies more about the Earth's surface or the land. So geologists have been known to classify faults. So it can be an active fault or inactive fault. When we pertain to active fault, this is known as any fault that is likely to have another earthquakes sometime in the future. The common consideration for a fault to be active is if they have moved one or more times in the last 10,000 years. So most likely, this occurs usually or this happens often. So the Philippines is not free from these activities or from these active faults. So the Philippines itself is parts of the Pacific Ring of Fire, which pertains that there are different active faults which were distributed in the different parts of the Philippines, as you can see from the illustration on your screen. So you see here that there are legends which represents the lines that you see from the map. So the active fault is represented by the straight line, and those traces represents another. Okay, so the traces therein is known to be a trace, of course, and those small traces is known to be offshore projection. And of course, if you can see that there's a bump in a line, then it can be known as a trench. Anyway, this specific legends speaks for the illustration that you can see from the screen. And why is it that fault is related with trenches? This fault and trenches is related with one another because they can be associated with earthquake. And not only that, but these features on Earth also indicates that there can be millions of minerals that can be found in here. So that is all about the active faults. Of course, if we pertain about inactive faults, we are pertaining to those faults that have not been or has not been occurred for a long time. But it can happen though. It's not just as usual as the active fault. Okay. So let us now talk about the subduction zones. Okay. So subduction zones are areas where tectonic plates converge, meaning they tend to move towards each other. So these particular two tectonic plates collide with one another as they move towards each other. So these plates or pieces of crust that have been moving in the surface of the planet for millions of years. So why million of years? Because in a span of time, we cannot really feel, it cannot really be felt na there's really a movement in the tectonic plates because it's just centimeters or it just moves in certain measures, but it happens anyway. So tectonic plates may be made up of a single type of crust or a combination of continental crust. So subduction causes a tectonic plate to slide under another and sink into the mantle because the denser oceanic crust slides beneath the lighter continental crust. So this means that if there are two crusts that we are pertaining to, the one that's going to sink is the one that is denser than the other material or than the other crust. So if we have oceanic crust and continental crust, it is the oceanic crust that's going to subduct. It's going to sink. That's going to sink compared to the continental crust. So more likely, the oceanic crust is beneath the continental crust. That's how subduction zone is being portrayed. So as you can see from the screen, you could look there that there's something there that is going beneath, and that is known as the oceanic crust. And the one that is being lifted is known as the continental crust. Okay? Take note that when we refer about subduction zones, there's something that is sinking and there's something that is being lifted. And of course, if there is activities like this, it can even result to volcanic activities, earthquakes, and even tsunamis. Okay? So the subduction zones that can be found in the Pacific Ocean is resulting because of the Pacific Ring of Fire. So that is all about the subduction zone. What else? If the plates that collide are made up of the same material, let's say if there are two crusts which is the same, continental to continental, one plate will not slide under the other. Instead, they both crumple together, meaning there will be no subduction zones if there are the same material that a specific crust has. For example, again, if this is both oceanic crust, then wala pong mangyayari na subduction zone. But in the case of continental to continental crust, and if they met, they will crumple together. So this now is the reason why there is a formations of geologic features such as mountains, particularly in the context of Himalayas. So this has been resulted because of the collision between the Indian plate and also the Eurasian plate. Let us try to look in here. So Eurasian plate can be seen at the top part of the map, and the Indian plate, let us look at here. It cannot be seen though. If they try to merge together or they try to move towards each other, it will result now to collision and formations of mountains. So the average rate of this subduction is estimated to be between 2 and 8 centimeters per year. So it takes a lot of time before there is really changes that happens. Okay, so subduction zones are also large boundaries and as such are capable of generating large earthquakes. Some subduction zones are able to separate place from other place because of the division that it has done. So the magnitude 9.5 Chilean earthquake in 1960 and the magnitude 9.2, which is very destructive Alaskan earthquake that happened in the late 1960s, occurred in subduction zones. So we can conclude that an earthquake strong or not, subduction zones, or let's say earthquakes can be generated in a subduction zones. So the magnitude of an earthquake is related to the size of the fault that is originated from. So because subduction zones are also the longest and widest faults in the world, they tend to create strong earthquakes. So aside from this, subduction zones are also areas where tsunamis can originate. So imagine what destruction can subduction zones do for the people and even for the surroundings. So earthquakes that are above 7 can result to tsunami, as I've been talking about before. So tsunamis can also be created when movements in the subduction zones create landslide in the seafloor. Okay, so let's try to look at a Philippine sea plate in here. So the Philippine sea plate that you can see here shows the locations of earthquakes that have occurred in the plate. If you try to click this link below, you would see there the illustration of the map that the locates places where earthquakes have occurred before. So since the Philippines is situated close to the subduction zone, it was created by the boundary between the Philippine plate and Eurasian plate. So this boundary now resulted in the number of active faults in the Philippines. So the Philippines now is known to be a place that have active fault lines. So let's try to look at this data. So we have 5 major fault lines in the Philippines, and this includes what you can see in the table, particularly West and East Valley Fault, Western Philippine Fault, Eastern Philippine Fault, South of Mindanao Fault, and even Central Philippine Fault. If you look at the table, you can conclude that the West and East Valley Fault and Central Philippine Fault are among those faults that exist in a lot of places. So we can conclude there that it is wide and it covers a length of those places. Okay. So the 1990 Luzon earthquake, which affected Baguio City and the rest of central Luzon, was due to the Central Philippine Fault. That's why you could see there that the Central Luzon is somehow part of the Central Philippine Fault. So another major fault that is being closely monitored by FIVOX, which is responsible for monitoring volcanoes and earthquakes, is the former Marikina Valley Fault, so which has been renamed as the West and East Valley Fault. So Marikina Valley Fault is known to be as one of the fault that has one of the most destructive earthquake that has been ever recorded in Philippine history. So take note, Marikina Valley Fault is now known as West and East Valley Fault. So according to the joint study conducted by the Japan International Cooperation Agency, or known as JICA, Metropolitan Manila Development Authority, or is known as MMDA, and FIVOX. When the fault moves and generates a 7.2 magnitude earthquake, the chaotic scenario will cause 34,000 deaths, 600,000 cases of injury, and 500 incidents of fire simultaneously in the entire Metro Manila. So this scenario is now known to be as the big one. So this is particularly frightening because Metro Manila is one of the most densely populated and industrialized region in the country. Thus, large damage to property and loss of life is expected. Of course, if the area is populated and it is known as densely populated, there can be a lot of lives that is in threat, or that is threatened rather. So that's why now there is a study known as Metro Manila Earthquake Impact Reduction Study, or MERS. So this was not commissioned to frighten the residents of Metro Manila, or to give anxieties, but rather to follow or reach and attain these objectives. Of course, first, to evaluate seismic hazards, damages, and vulnerability of the said place, and to prepare framework of master plan for earthquake disaster management, which is very vital since it can help the place to prepare on certain natural disasters such as those which are mentioned. So these particular situations now calls for a measure for mitigating the effects of its impending disasters and change of mindsets for preparedness and in handling the crisis when the big one finally comes. So it just gives them idea what probable causes it can ignite or it can have in their place if they have not prepared well, or if they have not act upon knowing the consequences. Okay. So the local agencies concerned, particularly the MMDA, answered the call by coming up with what is known as the Operation Metroyakal. Okay, I forgot to put the letter L there, but it should be Oplan Metroyakal. So this is known as an operation that will be followed in case the big one does happen. What we are pertaining about again, the big one, it's about an earthquake that can happen to Metro Manila. So under this scheme, the Metro Manila will be divided into 4 quadrants. So each with its own designated areas for evacuation. So this is also where relief efforts will be concentrated in anticipations of roadblocks caused by debris from collapsed structures from the tall buildings, which will make the delivery of relief goods nearly impossible for at least 72 hours after the earthquake. So under this plan, the evacuation sites are the Veterans Golf Courses in Quezon City. Yes, it's in the part of North. The Villamor Golf Course in Pasay City, which is located at the south. So the Field Sports Arena in Pasig City at the east, and the Intramuros Golf Course in Manila. So among those quadrants or those places as declared to be evacuation sites has particular open area, which is basically a golf course. Okay? So setting up the focal points for the rescue and relief efforts will make sure that resources are properly redistributed to the people and for a greater number of recipients. So it is also important that these informations are being spread to the people so that they will know or they will be informed where to go if they are asked now to evacuate, and what certain location can they get the relief goods intended for them for the next 3 days. Okay? So now let's try to discuss about the risk analysis that they have done. So this risk analysis again was intended for Metro Manila. So a long history of disaster and extreme weather events that happened in the greater metropolitan Manila area prompted the Philippine government to conduct this risk analysis, which was known as risk analysis for a ready, safe, and resilient greater Metro Manila area rather. So with the result that in May 2015, this was jointly undertaken with the help of an Australian government. So through Australian Aid and Geoscience Australia. So this study of risk analysis covered 16 cities and 1 municipality of Metro Manila and some parts of the provinces of Bulacan, Cavite, and Rizal, which you can see from here. So let me mention again. We have Rizal, Bulacan, Cavite, and Rizal, which is still part of the greater metropolitan area. Okay. So what is now the objective of this risk analysis? At first, to gain a clear understanding of the risk from natural disasters in the GMMA or in the Greater Metropolitan Manila area, or what are those risks? So since they are in industrialized place, perhaps ang mas susceptible or mas mangyayari sa kanila or earthquake. Okay, so that's one risk in the GMMA. What else? Identify where the risks are greatest. So of course, you're going to determine what are those places that has active fault lines. So they can be known or declared to be as the vulnerable sector or susceptible place, and find out how the damages can be reduced. So if they are deemed to be relocated, then it will be more likely to do so. Okay, so this study identified 3 potential risks for the said area. So first is the flooding in the areas of the Pasig Marikina River Basin. So second is the severe wind associated with tropical cyclones. And the third is a risk for a damaging earthquake originating from the West Valley Fault. So which includes what specific places? So West Valley Fault, of course, it will include the Mindoro, Panay, Sulu, and even the Sulu Sea. So informations now here was gathered as to how people live and work in the metropolitan area. So there were two advancement in technology that has been used to help in this risk analysis. So one is the light detection and ranging, or LIDAR system. So this was used to measure the profile of the landform, including factors such as trees, buildings, and other structures. So what they do in here is that they distinguish what particular measurement can this building can cover if in case that this has collapsed. Yes. Okay. So for example, that if this trees is about 10 meter tall, then it can also affect those areas that covers 10 meter tall, or it can even reach those areas. Okay, so aside from that, we also have digital elevation model, which is also known as DEM. So in here, it shows building types and density, population, density, land use, and the complex mix of age and type of buildings. So they try to learn also the elevations of these kind of structures and how could it affect the persons or residents nearby. So the result of the study was used to analyze the risks and effects of those hazards that they have cited. So through the analysis that they have conducted, there can be valuable predictions like the cost of damage to buildings due to an earthquake. So it will be estimated. So the damage associated with the ferocious winds due to tropical cyclones was also highlighted in the study. So it is known that wind increases in strength as it flows through higher landscapes. So meaning higher elevation, higher geologic features. So knowing the effects of wind strength allow visualizations of its damage to buildings. So billboards and shanties. So of course, ano na yung mga possible na gagawin ng mga tao if they have known that this particular typhoon or cyclone will be at this level or will be at the critical level, then they will try to reduce the hazards that they can spot now in their area. So if in case that there are areas that can be flown if there's already the cyclone, then at the earlier time they get to detach it from its place and put it in a safer place that it can no longer create destruction or even injuries. Okay, so the most susceptible areas were identified to be in mountainous regions in the east, in the areas along the West Valley Fault due to steep topography and the presence of informal settlers. So what can be the indicate or let's say implication if there's a steep topography? Of course, there can be debris, a large rock that can roll if there is some destruction that happens at the top part, and it can even affect the settlers there. So it can either injure them, can either destroy their properties. So also, flood projection was calculated from known rainfall figures. So during the tropical storm Ondoy, Metro Manila experienced severe flooding in areas near the Marikina Valley and San Juan River. So the study showed, I think I forgot to put the illustration here. Okay. So, as I was saying, there has been a damaging floods in the future. It has been expected already. So damaging flood waters are projected to move towards the city within 48 hours. This happened also in Isabela before when the people weren't that prepared for the flood rather. So flood heights and the inundation area were also seen in the models from the study. So one particular area of concern is Marikina because of the possibility of deep flood waters and the presence of wooden and makeshift structures that could easily be damaged by flooding. So there were two factors that increased the damage brought about by the flooding. So this is the deep flood waters and the presence of those makeshift structures. So the damage from earthquakes from the MERS was further intensified by the study. So a better picture of what could happen in the Manila area once the big one happens was painted after the results of the study were analyzed already. So this involved the identifications of densely populated areas and how different types of buildings are expected to behave when subjected to the shaking of the magnitude 7.2 earthquake. Not only that it is destructive enough to the Earth's surface, but it can also generate tsunami if it is near coastline, by the way. So areas that require actions regarding land use, implementations of early warning systems, and placement of relief and resources were identified to help the LGUs in planning, designing, and implementing mitigation projects and contingency plans. You see, research is very important since it gets to identify or somehow solve problems, specifically when you are conducting an applied research, because you are trying to apply what you have learned. Okay? So the tools developed through the study are expected to help understand, prepare for, and even survive in case that these hazards already come. Okay? So let's now talk about an earthquake. So the main idea in here is that these earthquake hazards can be classified into primary and secondary. So let us try to learn more about this. Of course, let's try to unlock first the idea about earthquake. So as discussed in the beginning of this chapter, from chapter 1 of course, Earth is made up of different plates that contains or that is constantly moving. So this movement now gives rise to the earthquakes. So what is earthquake? An earthquake is the sudden movement of the ground that releases elastic energy stored in the rocks and generates seismic waves. And as it has been mentioned before, when we talk about earthquakes, there are few that we cannot feel, but it is recorded, and there are also earthquake that is not felt and also not recorded, but it happens. It eventually happens because there's a constant movement of seismic waves. So these waves move outward from the source and vibrate the ground. So from the source, it moves to different locations depending on the extent of the energy that has been released. So earthquakes usually form along faults, which are fractures on the Earth's crust where rocks on one side of the break moves past the rocks on the other side. So there are collisions of rocks that is happening in the source. That's why there are fractures that happens to it also. That's why also that it creates hollow in the source. Kaya na nagkakaroon ng mga movement. So simply put, the initial movement that causes seismic vibrations occurs when two sides of a fault suddenly slide past each other, which generates an earthquake. So what boundary is we are pertaining now? So we have what is known as the, let me recall, transform boundary. What else? Strike slip boundary. And I forgot the other one. Okay. So the focus of an earthquake is the spot where the earthquake began. So as the ground ruptures in the focus, seismic waves radiate outward in all the directions. So, considering the source, if it releases a large amount of energy, then mas malaki po yung pupuntahan or mas malawak po yung pupuntahan mismo ng earthquake. So the epicenter of an earthquake is the point on Earth's surface located directly above the focus of an earthquake. So the focus again is yung pinanggagalingan ng source or is the source. And aligned to it, sa taas niya ay yung tinatawag na epicenter. So magkaiba po yun ha. Kung kailan nag-start ang earthquake, doon yung tinatawag na focus. At kung saan naman po nangyari or yung point na kung saan nangyari na siya sa earth's surface, ito na po yung tinatawag nating epicenter. So, let us talk about the earthquake hazards. So, earthquake hazards can be anything that includes a physical phenomenon which is associated with earthquake, of course. Kaya nga earthquake hazards eh. So, this may produce adverse effects on human activities. So, although many people think that this is somehow synonymous, it is useful to distinguish a hazard from a risk. So when we talk about a hazard, this is already a natural phenomenon that might impact an area or region. So regardless of whether there is anyone present to experience them or not. So hazards can be reduced. If you have spotted it already, then you try to move or manage it. While risk refers to anything that could potentially be lost when the hazard occurs. Okay, so if there's, let's say, there's an open wire in this certain place. Open wire, therefore, it's known as the hazards. Can we do something to prevent this? Or can we do something to elevate or reduce the risk from this hazard? Yes. So, what is now the risk in here? The risk in here is that some organism might be injured or might be killed from the open wire, since it can release electrical charges which can no longer be withstand by the people. So, what are you going to do? If you remove that hazard, you remove also the risk that is present there. But if you retain or if you have not done something for the hazard to be reduced, then of course, more likely, mas mag-i-increase po yung risk, which is known to be a potential loss. So hazards are measured in terms of units of energy and strength of the shaking among others, while the risk is measured in fatalities or amount of damage. Yes, exactly. Ulitin po natin, the hazards is yung maaaring maging problema. Maaaring maging problema if may namataan siyang victim. And risk naman po ay makikita once nangyari na mismo or may kababalaghan or kasamaan na nangyari from the hazard. So, it can result to fatalities or damage. So, anything that can be moved, fall off, or be toppled, even the ground, or when the ground starts to shake and cause emotional and physical pain, is an earthquake hazard. Take note of that. So even with the scientific and technological advancements that we are enjoying right now, no single instrument yet in existence can predict when exactly an earthquake will happen. So this makes the risk from earthquake a real danger to anyone exposed to this hazard. So these earthquake hazards now are generally classified into two, which are primary and secondary. So when we talk about primary earthquake hazards, we are directly pertaining to the results of movement of the ground. Take note of the term. It is the direct results of the movements of the ground, or this is the direct results of the earthquake. So here are the ground shaking, landslide, liquefaction, and even the surface rupture. Let us talk more about these primary hazards. First, about the ground shaking. From the words itself, alam na natin kung ano yung definition niya. But anyway, for the discussion's sake, let us look through it. So, ground shaking can be both seen as hazard, which is created by earthquakes, and a trigger for other hazards such as liquefaction and landslide. So this is described as the vibrations of the ground when an earthquake occurs, usually recorded in terms of intensity. By the way, when we pertain to magnitude and intensity, this is different. But just to give you an idea, the magnitude pertains to an energy and the intensity pertains to the impact or to the effect of that magnitude. That's why, let's have an example. Magnitude 7, this is the energy now. How destructive it is, it can be seen in the intensity. Okay. So, kung ilan yung namatay, ilan yung nasira, magkano yung mga nasirang or na-lost na property, etc. Anyway, it will be discussed further for the next discussion that I'll be having. So, most of the damage from earthquakes is the result from the shaking, which is caused mainly by the seismic waves passing beneath roads, buildings, bridges, and other structures. For example, ground shaking may cause a building's exterior walls to crumble. So the separated materials could cause injury. So the debris could block sidewalks and streets, and its collapse could bring down utility lines. It can break communication lines. Maaari rin na magkaroon ng problem with the water system, electrical system. So before, many churches in Bohol collapsed due to the ground shaking, which was caused by the magnitude 7.2 earthquake, which has occurred last 2013. Take note, if a certain place is near coastlines, it can generate tsunami. But if it's not near coastline, then it can just covers earthquake. Okay, so the first primary hazard that we talk about is ground shaking. Next, landslides. This is very typical or common to you already. So strong earthquake and ground shaking is, of course, greatly affects or increases rather the likelihood of landslides in areas which is susceptible to ground failure. So if the ground is saturated with water, the shaking will result in more landslide. So ano nga ba yung sinasabi na saturated? So let's say there are no more spaces that the water can fill in the ground. Kaya siya sinabing saturated. Because the soil can no longer absorb the water. That's why nagkakaroon siya ng flooding. So, landslide includes a wide range of ground movement such as rockfall, rock slide, debris slide, and even shallow debris flow. So, typically, if there is a magnitude 4 earthquake, this is already considered as strong enough para matrigger niya na magbagsakan yung mga rocks. So although gravity acting on a steep slope is the primary reason for all landslide, there are also other contributing factors. Hindi na natin maiiwas na gravity can be a reason too why certain rocks fall into low-lying areas. So what are those contributing factors? First is the over-steepened slopes created. Let me look if I have put it in here. So I think I have not. Okay. So over-steepened slopes created by erosion in rivers, glaciers, or ocean waves. What else? Rock and soil slopes weakened through saturation by heavy rains. It can no longer be anchored into the soil. That's why it slips through its roots, or it slips from its place. So excess weight from accumulations of rain or snow, and weak slopes due to the stockpiling of rock or ore from waste piles or from human-made structures. So these are reasons also why it can trigger landslide from specific areas. This happens yung mga matataas na mga lugar. Okay? So aside from the ground shaking and landslide, we also have liquefaction. So this recently happened in the Philippines, particularly in Leyte. So this picture was garnered from online radar. Doon sa nangyari na liquefaction in Leyte. So liquefaction occurs when sand or soil and groundwater are mixed during the shaking of a moderate or strong earthquake. So it is a hazard, yes. So when the two are mixed, particularly sand or the groundwater, the ground becomes very soft and exhibit properties similar to that of a quicksand. So kaya siya liquefied na sinasabi. Kasi pwede na siyang mag-move. Hindi na siya solidified. So when liquefaction occurs under a building, the building may start to lean, pwede rin na mag-tip over or sink for several meters. So the ground will eventually firm up again after the shaking stops and the water has settled back into the ground. But the damages, of course, will no longer be, hindi na po pwedeng bawiin pa. So liquefaction is a hazard in areas that have groundwater close to the surface and have soil which is sandy. Which proves naman talaga kasi malapit siya sa tubig. Okay. So, knowing that the people have moved to the top part of that place, since sabi nila they can be more safe there, hindi nila naisip, or hindi nila na-anticipate na too much rain that happens there can also liquefy the soil. So, that's why it resulted to this disaster. So, liquefaction has been identified as responsible for tremendous amounts of damage in historical earthquakes around the world. If you have seen the news from Leyte, where a specific person or one female worker from different place has lost 20 or more of his relatives, of her rather, kasi babae pala siya, of her relatives because of this. And there is also one boy who were saved from this catastrophe because he was able to hide in a refrigerator. So liquefied soil will force open the ground cracks in order to escape the surface. So this ejected material often results in flooding and may leave cavities in the soil. So it will leave cracks on it. Pansinin ninyo, natabunan na yung mga property, yung mga bahay, and even the trees were tipped over. So floodplains, if you recall doon sa Earth and Life Science natin. Floodplains is typically a place where flood happens there. Sandbars, abandoned river channels, coastal areas, swamps, river deltas, and reclaimed lands are highly susceptible to liquefaction because there is a nearby water reservoir. So areas in the Philippines that are prone to liquefactions includes Marikina, Pasig, Taguig, Caloocan, Malabon, Navotas, Muntinlupa, Pasay, Las Piñas, and even parts of Pateros. If you recall Pateros, yung nagkaroon siya ng nagkaroon dito ng, I cannot recall the term. Kumbaga, garbage landslide, siguro. That's not the right term. But ang nangyari dun, because of there's a piles of garbage that it has covered residents there na sa sobrang dami ng basura. So, areas in reclaimed land such as Rojas Boulevard or Macapagal Boulevard are also at risk. So, some areas in the provinces of Pampanga and Nueva Ecija are at risk as well. So, a perfect example is the liquefaction that happened in Dagupan City during the 1990 Luzon earthquake. And of course, we wouldn't want that to happen in any other sides of the Philippines, knowing the effect that it has for the people. So we have the third, liquefaction, and the last primary hazard is the surface rupture. Anyway, the secondary hazard would be discussed for the next meeting that we will be having. Okay? So para hindi masyadong hahaba tong video. So, surface rupture. So, when an earthquake occurs, ground rupture happens only at the area where the fault zone moves. So, these structures built adjacent to the fault will survive, while structures built across these zones will collapse. Of course, sa mga active lines or active fault lines na naman to nangyayari. So, ito yung nakita nyo, fracture, opening, mga cracks. So, surface rupture is an offset of the ground surface when fault rupture extends to the surface. So, hindi lamang siya at the bottom, but it also being evident to the Earth's surface. Kaya sinabing surface rupture. So, any structure built across the fault is at risk of being torn apart as the two sides of the fault slip past each other. So, they tend to move from different or opposite direction. So, structures that span a surface fault are likely to suffer a greater deal of damage. Of course naman, syempre nga andun yung pinaka-main na epekto niya eh. So, a winning strategy is to avoid building across or near these hazards or active fault lines. So, surface rupture is not a single line with a fixed width, but a zone with variable width where fractures have developed. So, as long as there is a line that the rupture can penetrate to, then pwede niyang pasukin yun. So, this is now the areas known as deformation zones. Okay. So, FIVOX recommends a 5-meter buffer, which is also known as a zone, which is also known as protective barrier from the edge of this deformation zone for building structures. So other countries such as the New Zealand or in California, USA have larger protective barriers. So one of the best examples of surface rupture which has happened last 1999 was Chichi earthquake in Taiwan under the Beifeng Bridge. So the rupture lifted the upper stream to a height of about 5 to 6 meters, which created a new waterfall. So you can see there the normal structure of that bridge, but apparently because of the surface rupture, it turns into a new waterfall. Of course, this particular surface can no longer be traveled to since there is a damage there. What else? There's also, in the 2013 Bohol earthquake also lifted a mass of land 2 kilometers long, about 2 meters high. Okay, napakataas nga naman noon. So, geologists from FIVOX found a surface rupture which is part of the reverse fault called North Bohol Fault, about 6 kilometers long also. So next meeting, I'll be discussing about the secondary hazards which pertains or which is a result of the primary hazard. Ano ulit yung mga primary hazard? Liquefaction, landslides, surface rupture, and even the ground shaking. So this includes tsunami, siege, flooding, and fire. Okay? So this will all be discussed next meeting. Okay? So that will be all.